So thank you all once again for joining us for EdTech Tuesdays with Tim's and Friends. And we're here with Mr. Burgess Jeffries, and I'll give him an opportunity to introduce himself very shortly. But this is Bringing Math to Life with GeoGebra 3D. So those who are here have already registered. And so basically what this is, the EdTech Tuesday with ATIMS and Friends, is a continuous series of tech tools or applications that you can use and add to your tech toolbox. Today is October the 10th, so this is the one that we're doing. If you missed out on the other two, we do have recordings for those, just like we will have a recording for this one as well. And then you have the other ones coming up in November and December. Those two fell in line some kind of way. Both are dealing with artificial intelligence. And then we have a few more starting in the next semester. So if you have an opportunity, please sign up for more or pass them along to a friend so that they can sign up as well. So thank you all for being here today. If you hadn't had an opportunity to listen to Tim Talks, that's our new Technology in Motion podcast that we're pushing out, making people more aware of what the state offer. So the different initiatives that the state has, we want to make sure that you are aware of those. And so our meeting norms for the day, we are all learners. While we have a different level of understanding of topics, we're all able to learn from one another. We want you to be fully present. Our schedules are always busy, but it's important to take the time to participate in professional learning. We all work together. We collaborate to maximize our impact on student achievement and success. Every child, every chance, every day is a non-negotiable. My name is Pernell Allen. I'm the Alabama Technology and Motion Specialist located at the University of Alabama at Birmingham, UAB. Go Blazers. Those other universities that you see over there to the left or where the other ATIM specialists and the regional in-service centers are located across the state. If you need to contact me, that's my contact information right there, pdalle23@uab.edu or pallen@atim.us. If you're on Twitter, or should I say X, you can follow me at UAB_ATIM. All right. And these are the regions that I serve, but no matter what your region is or your LEA is, I do say welcome today. And with that being said, I'm going to stop sharing my screen and pass it to the gentleman of the hour.
Hello, how's everyone doing today? My name is Burgess Jeffries. I am a learning innovation specialist with Ed Farm here in Birmingham, Alabama. I see that we have a few people from different parts of Alabama, so it's always good to know that I'm reaching more fellow educators. A little bit about myself. I was a math teacher, classroom math teacher for about 17 years before I left the classroom and started to work with Ed Farm. I taught math anywhere from Algebra 1 all the way up to AP Calculus. And I've always had a affinity towards technology since I was like a child, 10, 11 years old. So any way possible that I can fuse the two together, use it as a tool, I am all for it. And I always like to kind of jump in and try new things out. So one of those tools that I ran across a little over 10 years ago is GeoGebra. By responses, whether it's a show of hands or dropping it in the chat, how many people have heard of or have used GeoGebra before? I'm trying to see. I see one thumbs up. Okay. Now, okay, heard of but not used. Okay. So I'm gonna go and show a few things or try to highlight a few things that I thought were like just mind blowing when I first found out about it. So even though it is a calculator that is open source and on their website, there are numerous creators and I've seen material that range outside of the subject of mathematics. So when you search around, and I'll kind of show you how the platform works online, if you ever want to just pull down different things that have already been created, make sure I get you an opportunity to see those things in action also. The other thing, I hope everyone is behind some type of laptop or mobile device because this is going to be like a work along. As I kind of show you things, I want you to kind of follow along as much as possible, just so you can get a feel for how easy it is to actually use. All right. So let me get started by sharing my screen. All right. Am I coming in through? Can everyone see?
Yes, we can see your
Okay.
screen.
Okay, cool. That was the main thing I wanted to know. All right. So this example is going to be a straightforward one. I'm going to show you basically how we could bring certain things to life. I like to use this as an example because I actually got a chance to travel to Egypt in 2017. So that is actually a picture that I took that I'm showing right there with the pyramids right there in the background. I played around with it to do some other cool stuff to it, but that is a photo that I did take. All right. So we're going to be modeling the Great Pyramid of Giza. And all of these are different pictures that I took on my trip along out there in Egypt. All right. So GeoGebra is an open source graphing calculator, basically. The Great Pyramid of Giza was built in the 26th century BC in a 27-year span. It is the oldest of the seven wonders of the ancient world and is the only one to remain largely intact. All right, so this open source graphing calculator I ran across in 2009. What I love about it most is you have so many users from around the world. It was actually founded by a guy from Germany. It was a graduate project, and he was starting to create like this graphing calculator, and his professor thought he really had something that he can continue with. So from there, it became a company and they kept building upon it. So one of the features that I will be getting in today is the 3D aspect. When I first started using it, it was pretty much all two-dimensional. So I'm kind of glad that they were able to build upon it so that we could do things like we're about to do today. So as you can see here, I did a little presentation. Initially standing at 146.6 meters or 481 feet, the Great Pyramid was the tallest man-made structure in the world for more than 3,800 years. Over time, most of the smooth white limestone casing was removed, which lowered the pyramid's height to the present of 138.5 meters or approximately 454.4 feet. At its tallest height, the dimensions of the pyramid were 280 royal cubits, which is roughly 146.7 meters or 481.4 feet high, and a base length of 440 cubits, which is roughly 230.6 meters or 756.4 feet in length. All right. So make sure that you do try to jot down some of these measurements because we will be going back to these a little later. I tried to highlight it as much as possible. If you see those things underlined in blue and underlined in red, those are the numbers that we're going to play around with. All right. So you can take a screenshot if need be, because once I go off to the next screen, I might have to ask someone to tell me what was the height, what was the base length. So just make sure we have that jotted down, and we're going to go on to the next slide. So this is the Great Pyramid of Egypt. This picture is not my picture. I pulled this one off the internet. So let's keep going. So these are some of the things that we can do. I'm a big fan. As much as I love technology, I still think there is no substitute for paper and pencil. I think that's kind of like if you were a bodybuilder, there's no substitute for the gym, right? So as a mathematician, there really is no substitute for getting paper and pencil, right? So I do like to jot things down, kind of get my ideas out on paper first before I start leaning in on the technology. So I'm not really 100% one way. I try to be down the middle as much as possible, but I swing towards the direction of technology when I can. All right. So I took a picture, I jotted down the height, I look at the base length, and then the base length is a square. So I drew a square. All right. So these are just little notes that I'm trying to jot down because this is going to turn into a 3D model. All right. I cannot see my mouse. Hate that. So we have 2 dimensions and then we have 3 dimensions. We live in a three-dimensional world. This has always been my issue when it comes to teaching some things in mathematics. We focus so much on two-dimensional things where everything around us is in three dimensions. So I'm very big on, you know, thinking of things in terms of like physical space and how things will actually appear in real life. So let me close this out. What are some other three-dimensional all of these
objects that
things
you
that
can
you
think
see
of?
here are all three-dimensional type of objects. These things can be modeled in GeoGebra, whether it's a cylinder shape or we have a triangular, I'm gonna say an equilateral triangular prism, rectangular prism. As you see here, that's a picture of the Apple Store. That's Fifth Avenue, New York. That's the Louvre in France. You have cones. So there's all sorts of shapes and things that you can just go outside and see. And these all represent things that you can model in GeoGebra. So this is where we're going to get to it now. If you can, take a screenshot of what that says there. So we're going to use GeoGebra to model this and based on this question here. So this says the Pyramid of Giza has a height of 480 feet. It says the length of each side of the base is approximately 756 feet. What is the total surface area? Now, I'm not going to go into the math part of it as far as jotting this down and figuring this out on paper using geometry. All I can say is that it is semi-lengthy, right? Depending on your student or the level that they're at, their level of understanding, it might take a full sheet of paper to figure it out and piece all these things together. But using this technology, we can actually get the surface area just off of this information alone. And this can happen within like a few seconds. All right. So I'm going to stop sharing my screen and I'm going to load up the GeoGebra website. All right. So give me one moment as I load up the website. All right. So the GeoGebra website is geogebra.org. And as you know, GeoGebra comes from geometry and algebra. They kind of fuse the two words together to come up with GeoGebra. So geogebra.org is the platform. All right. So who all remember, if you can put it in the chat, what was the height and what was the length of the base? If you all can remember in the chat, what was the height and what is the length of the base? Let's see. Do you have anybody here? Anybody here? Okay.
Waiting on somebody to put it in the chat. There it goes.
480. Okay, we got a 480 height. And we got what was the length of the base? I mean, I could flip back to my presentation, but I'm trying to see.
They put it in the chat.
756 feet. Okay, so we got the two numbers in there. All right, so here we are. We're in the GeoGebra website. The one that if you scroll down, right, you'll see right here where it says 3D calculator. 3D calculator right there. So that's the one that we will click. So we go to geogebra.org. We go to the 3D calculator. And now you'll see that we have a X, Y, and Z axis. I want to say the Y axis is green, the X axis is red, and the Z axis, which is going into the air, to the sky, that's in blue. Over here on the left side, we have two different things. We have algebra, which allows you to put in commands and type in and do your calculations and things like that. Then we have tools, the button that says tools. And tools have like shortcuts to create certain shapes. Like you can create a circle based on where the center is, or you can create a circle based on how long you want a radius to be. So they have all these different types of commands right here to make it a little easier. All right. So what I want to start with is the base of the triangle itself, of the pyramid. And I'm looking at the chat and we have something that is 756 feet. So in algebra mode, and there's many ways you can approach it. You don't have to go the exact same way that I'm going. Once you're more familiar with how you can create things, but this is kind of the way that I think is easiest to follow. So I'm gonna start with setting a point, like a starting point. And for most people, I always ask, like, what's a good starting point if you want to at least lay down your first point so we can start figuring out where we're going to start building this thing out? What would you say the easiest point would be? There's technically no wrong answer, but there's a point that I always like to start with as much as possible.
0, 0.
There we go. So we got a 0, 0. That is correct. But I want to add to that 0, 0. We're in 3 dimensions now. So X is 0, Y is 0. But now that we're talking about 3 dimensions, I also want to take into consideration that the Z axis is also 0. It'll still put it in the same place though. But the reason why I like to focus in on making sure that all 3 numbers are there, because it forces them to constantly think 3 dimensions, 0, 0, 0. So now instead of ordered pairs, we're talking about ordered triplets. That makes sense? So 0, 0, 0. And notice, if you put it in parentheses, comma between all the zeros, you hit enter, it sets a point and it says A is equal to this point. And if you look right here on the axis, notice that I have a point A sitting right here where all of the axes meet. So that's my first point. This dot is blue. This dot is blue. If I click this dot, I can hide it. Notice it disappears, or I can click it again and it's showing again. Right. Now, all right, so we got that out the way. So now we want to take into consideration that the side length, right, I think was 756 feet. So that means I want to set another point along this axis so that I can get that length. So 756 is my X, my Y is going to be 0, my Z is going to be 0. So I have the 2 points that I need to kind of get started. Now, if you notice right here on my graph, this number stops at 5. So there's an easy way to kind of squeeze everything in. You can scroll and zoom in and zoom out. I like to go straight to it by using this gear. If you click this gear, you can do zoom to fit. See that? So if I zoom to fit, it'll resize it. Now I can see A and I can see B. So it just resizes it, squeezes everything so that you get a good look at everything that you have along your inputs on the side. Now, the base, and remember on that sketch, there was a base. It's sitting on top of a square base. Now, I can draw this out there's a couple of ways. It all depends on how you want to challenge the students. A challenge would be, what would the other coordinates be to create that square? And it forces them to start thinking about moving left and right, up and down, those types of things, right? We're not going to do that today. I'm going to show you another feature under the tools so that we can get this square base like within a couple of seconds. So if I click right here on tools, right here, I click on tools and I'm scrolling, they have something here called a regular polygon, this one here. So when you do a regular polygon, it creates whatever polygon you tell it to, and it makes sure that all the sides are equal. And since this is a square, I know all the sides will be equal. So if I just go to a regular polygon and click it, if I click point A and I click point B, it's going to ask, okay, so how many vertices do you want? And since it's a square, I know I need 4 vertices, and I hit OK. And what it just did was it created a square base, and all of the lengths are exactly the same as it is from point A to point B. So everything, it has a length of 756. Now I'm going to click this mouse. You click this mouse to deactivate that tool. And so you can come down here and scroll around. And so now I have a square base. Same thing. Every time I add things onto my screen, I always click the gear, I zoom to fit, and I resize it, give it a good look. So I'm looking at a square base right now. Now, I'm going back into the chat because I think the first thing everyone remembered off top. Yep, there we go. And remember, this has a height of what? 480 feet? 480 feet? So how do we turn this square base, which is 2-dimensional, into a pyramid, which would be a 3-dimensional solid, right? And notice, see how it has solids here? This one has pyramid. We could do that one, but the one that is the most efficient will be the one that extrudes to a pyramid. And the reason why extrude to a pyramid is a better one is when I click on this tool, the only thing I have to tap on is the square, and it's going to ask me how high do I want it to go. So it literally asks for the altitude, and I believe the altitude was 480. So if I type in 480, it's going to actually pull that up and create the pyramid right then, right there. So now, same thing. I could just click the gear. I can hit zoom to fit, and now I have a good look at the pyramid. So we basically modeled this pyramid right here on our computer screen. But the question that it asked before is, based on the height being 480 feet and the length of the base, the side length of the base being 756 feet, it wants to know what the surface area is, right? Now, the area of a square is easy, right? If we turn this upside down, and I know that this side is 756, and I know that this side is 756, then basically I just multiply 756 times itself, right? I square it, and I at least know the area of the base. But there's 4 more sides we have to take into consideration. And all of these are also triangles. So now we have to think about, okay, what's the area of these triangles? Now, once again, there is a math way of doing it, paper and pencil, which gives you good brain exercise. But since we're just using technology, they have a tool that can do that like in a split second. All right. So I'm going to scroll out just a little bit so that we can see this. And then I'm going to introduce this other tool that I really love using. It's called a net. All right. So when I click the net button, all I have to do at this point is just tap the pyramid, and look what it just created. I'm going to hit this. Remember, I'm going to hit this mouse to deactivate that tool so that I won't keep doing that over and over again. And so now I have a net of this pyramid. Now, if I go back here to algebra, notice everything is color coordinated. So this pyramid that I created earlier was orange. I want to hide that one. Well, before I hide it, I want you to see this number. This number right here that is showing you is the volume of that pyramid. But remember, this didn't ask for the volume. This asks for the surface area. So I'm going to just hide this. And what we're looking at is a net, which means if I drag this, see that if I drag it, this is the pyramid itself, right? Or I can just open it up. And when I open it up, this is how the pyramid looks when you unfold it. And now we're looking at a triangle here, right? We're looking at a triangle there. So we have 4 triangles with a square in the middle. And this net feature alone does that. So just by doing a net, it went ahead and calculated all of the area right there of all the shapes. So the surface area, if we were to unfold that and just actually do the measurements ourselves, you'll add up all these areas and you'll come out to this number here that's already being calculated. Are there any questions about any questions about it? Has anyone gave it a shot, or anyone's kind of working along trying the tool out on their end?
It's just mind blowing to me. Loving it.
But this isn't this isn't even the half of it. Like, I always like to kind of show when I use this GeoGebra, I like using the website because I can type fast. I have more screen space. So I'm gonna go ahead and let me see. I'm gonna close this one up, right? I'm gonna do I want this to zoom to fit. So here it is here. So this, another cool thing about this, you can actually have your students become a little creative if they want to be, if they don't want to go with all blue, you can click on each shape and look right here. I can choose a color. I can go with a red here. I can click this one, go with a different color by hitting the plus sign. Let me go with a green there, and And notice how I'm just changing these colors around and trying different colors. Is there a yellow in here? Yeah, there's a yellow. So I've gotten the colors changed, right? Now, they're also part see-through. If I don't want this to be see-through, I can also go to where the colors are and I can drag this all the way up. So when I drag that up to 100, what happens is notice how dark that red is. That means it's no longer see-through. So if I crank this up a little further, let's see. And I'm just going to play around. Just going to make this a little darker. Let's see, make this a little darker. And I'm just noticing something. This is the first time I've ever seen this happen. I noticed when I close this all the way, some of those colors starting to disappear. It might be a glitch on the website. That's the first time I ever seen that happen. See how it's see-through all of a sudden?
Yeah.
Move it. It might be a glitch on the website. It might not even be happening for other people. It's just happening to me right now. So,
of course, you demonstrate. That's how it works.
Of course, but it's all good. I'm gonna open this up, and the square base, I want that to be 100% see-through, but the rest of it. So, everyone saw how easy it was to kind of create a square and then extrude it, and it right there was a pyramid. And then when I went to net and I clicked it, it opened it up and it found the surface area. It's like very, very, very efficient way to do certain things. Oh, yours went clear as well. I will send a message to the founder. I actually met him. He's a very brilliant guy. But I might send him a message on Twitter and let him know, like, hey, I was doing a demonstration and these sides were going clear and they're not supposed to go clear like that. So maybe he can talk with his developers or something. Okay, so all right, so here it is. I'm gonna show you a couple other things. So right up here, you see right next to mine, yours might say log in. All right. I'm just letting you know, yours might say log in. I log in using my Google email address. And the reason why I like to log in on this website when I create things is when I click these three dots here, it allows me to save to my account. So when I log in, I can save it and I can call this TMS and Friends, right? Isn't that what you called it?
Yes, sir. Yes, sir.
I can call this TMS and Friends, right? Tim's and Friends. And I'm going to hit save. And the reason why I'm going to do that is if I ever leave this website or if I cleared everything out and I made it disappear and I went to GeoGebra.org, I can always get back to anything that I saved by clicking on my emoji right here. Yours might have an initial. I use the picture. So I click on it and look where it is. It's the first thing. It says Tim's and Friends. And when I click it, it'll pull it right back up. Everybody see that? So you can create things and work on them, play on them. You can come back to them. All right. So that's the reason why I say, okay, if you can log in using your Google account, to do so. Now, this is the other thing. Let me ask this question in the chat, and I'm going to ask it out loud too. Are you familiar with augmented reality? Who's familiar with augmented reality, or do they know what it is? And how much time do I have, Pranell? Am I still?
Good. 30 minutes.
Okay. Everyone loves to say no, but everyone does know what it is. They probably not sure. They probably wasn't told this, but have not used it. Okay. So, just the word itself, augment. I looked up some stuff in the thesaurus, and the synonym or an equivalent meaning I was able to find in a thesaurus is to enhance. All right. I Googled different definitions, and I think one of them said to make something greater by adding to it. I'm trying to think what was another one. It was a couple other things, but I just like the simple thing of enhancement. All right. So when you all take pictures on your phones, or a lot of times, some people like to just take the picture and they share it or they send it to someone else. Others, they like to take the picture and they like to doctor it up a little bit, right? Anytime you doctor up something, right? You take a picture, but then you doctor it up. What you're doing is augmenting that picture. All right. So when we talk about augmenting reality, that means you're adding something to the real world. That makes sense? You're adding something or you're enhancing the real world. A good example of that is the number one example for augmented reality and mass adoption was summer of 2016. There was a phenomenon that hit America from coast to coast. Does anyone remember what game everybody was outside playing? You can come on the mic and say it, or you can type it in the chat. I don't want to just tell. I'm trying to see how many remember that moment in time, because it was a
there you go. Yeah.
Pokemon Go. So Pokemon Go is like the first time as a society people really interacted with augmented reality the way that they did. All right. So you had people outside walking around pointing their phones at whatever, right? Going to all these different locations because it was using your location. You had to go to all these little special areas. And next thing you know, you're catching these Pokemon everywhere. Now, you have people like, oh man, I didn't catch it. And then, like, if you didn't have a phone, you're like, there's nothing there in front of you. Like, what are you talking about? Right. But when you do look on the phone, you'll see like they're pointing at the ground and there's a little creature sitting right there in front of them. What happened is they overlaid some digital things and brought it into the real world, into real space. So it's basically like the real world with a digital layer on top of it. So that's what we mean by augmented reality. So on the website, GeoGebra 3D does not have an augmented reality feature, right? But when you go mobile, like using their app, then you can use the augmented reality feature. So what I'm going to do is I'm going to pull up, I'm going to share my phone screen in one moment. And what I'm going to do, I'm going to stop here. I'm going to share my phone screen. This is my phone now. And remember, I saved it to my account so that I can pull it up on my phone easily. And right there it says Tim's and Friends. All right. So if and you can see my mouse, right? Is my mouse showing on the screen?
We can see it. Yes.
So these three dots, like if I press it, it brings up this menu. And then what I'm going to do is go to where it says open in app. And then notice up top, it says 3D calculator. So I hit open. I don't know why it's going clear. I really got to get with them. I got to let them know that it's doing something a little funny right now. It's not supposed to do that. All right. So notice I'm playing around with it on my phone. All those things that I typed before, they're all here. Now you all have to excuse me because I'm about to activate my augmented reality. You see where it says AR right here in the bottom left where my mouse is?
Yes.
When I tap that, it will activate my camera. I'm in the middle of moving things and buying a lot of stuff to furnish my house. So I got boxes everywhere. So y'all have to excuse me. I'm going to try to just point directly at the ground in front of me. All right. So it's detecting a flat surface. And when you're detecting a flat surface, you want to make sure that your phone is parallel. You don't want it to tilt. You want it to be directly on top. And then when you tap the screen, and the reason why is so that you can have, it could be more accurate with its placement. And does everyone see how I've created a triangle in not a triangle, but a pyramid in augmented reality that I can literally interact with? And note it's not real because if you see how it's laying on top of my hand, but it does look like it is actually there in front of me. Now I can stretch it, I can make it large, I can make it smaller. Let's see. Let me turn that plane off. I'm gonna hit the gear. and I'm gonna turn the plane off. Okay, so it's just the floor. And see how I have an axis right here? If I want to, I could turn all that off also, but I'm gonna leave that on. Does everybody see how? And then this is cool because you can literally go inside of the and really interact with these everywhere, like as if it were like really right there in front of you. Oh man, I just hate that it's going clear. It kind of messed up when it did that because I like to put objects right inside of it. And when you close the pyramid, you can't see what it is until you open it up. So I'm just mad it's going clear like that. That's not supposed to happen, y'all. It's something going on. It might have to be like the developers on the website on the back end have to figure out why it's doing that. But any questions there?
No, you just got a few that said it's so cool and that the kiddos are gonna definitely love this.
Yeah. So the augmented reality piece is like really like one of my favorite things. Oh yeah, who had a question? I'm reading through some of the chats right now.
It's the last question popped up. It says, "Are you on the app or the website?"
Right now, on what I'm sharing this directly from the app on my phone. So the augmented reality piece happens if you download the app to a mobile device. So the first half of my presentation, I was doing everything right there on my computer, and then I saved it. And then when I went to my phone, I pulled up what I saved from my phone. So like right now, this is the GeoGebra website. GeoGebra.org. So this is the GeoGebra website from the phone that I'm showing right now. So because I type much faster, using a full-size keyboard and I have more screen space, I like to do most of my things right there on the computer first, and then I just open it up from my phone whenever I want to see it in augmented reality. You can do it 100% from the phone, but it just takes practice, to kind of type through everything. It says, is there anything from K5? So I'm gonna go ahead and stop sharing this screen so that I can answer that question. All right. So I'm gonna stop this one here and I'm gonna go back to the website because that's the main thing I want to make sure that you all had an opportunity to actually see. So I'm going back to the website and I'm gonna go to geogebra.org. And this is like your main landing page. There's a few things I'm gonna run you through. Notice right here, it has math resources, community resources, identifying angles around us. So it's like a lot of things that have been created by the GeoGebra team and other what they call power users, right? So let's see. If I go to math resources, okay, there we go. Now look what we have here. It says, look there, across grades 4 through 8 to enhance student exploration and practice. So yes, there are things that can be used for the earlier ages. Let me just look at number sense just to see what they have. We got coordinates, decimals, exponents, place value. Place value might be one of those things. And see, look at that, 4 through 5. Factors and multiples. Let's look at this. Visualizing the greatest common factor using a model, finding the greatest common denominator, exploring multiples in a grid, common multiples in a hundreds grid. So factoring trees, that's the one I really like. I love factor trees. So let's see. So there we go, factor trees. That is definitely divisible by 3. So I'm gonna put a 3 here. And look at that. So 3 times 77 is 231. But 77, that's definitely divisible by 7. And then as you can see right down here is the prime factorization. So that's something that can be done at an early age. And they can kind of physically kind of see how those go. You click new number and then it's new numbers and you just kind of go from there. And look at that. 2 times 5, 7 times 7, boom. And now there's 490 expressed as prime factors. Any other questions there? So that's just one of them. So yes, there are things for the K through 5, I believe. Here's another thing. So those were some of the things on the math resources, right? There's another way that you can search. I like going to where it says resources. So when we click on resources here, they might have changed it out. They used to do it another way. Okay, so they did redesign it. There was like this cool map that you can click and you could see it kind of point in all these other directions. It looked like kind of like a factor tree in a sense. When you click it, it'll just drop out more lines and then you can kind of zero in on other things. So these are like all the things that are built in. So like if you don't know how to create things from scratch, there are plenty of things here already built out for you to use. And it's just a good way for them to visualize and really explore different concepts. Let's see. Let's go to people. So these are a lot of people right here. Like it's all sorts of names that you'll run across. I've run across a few names and I've actually started following a few names, right? So Steven Silvestri is one that I follow. He's a brilliant guy, man, like extremely brilliant. Most of the things that he creates and offer up here on the website are like games. Like he has these ideas and he turns learning into like a fun game. So he has some really cool designs. Marcus Hornwater, he is the actual founder of GeoGebra. So I follow him. Tim Brzezinski, he's in Connecticut. He's a brilliant guy. He's good at modeling things and he's a very curious individual. So like the things that he creates are very well thought out and they're like good to use for like student assessment and student practice because he's very big on discovery learning. So like as they play around with things, they'll start noticing things or the goal is for them to notice things and ask more deeper questions. So he kind of try to facilitate through that process of discovery. And Steve Phelps is another guy, extremely brilliant guy. He's the guy that trained me on how to use GeoGebra over 10 years ago before there was even augmented reality. So I like to follow these in particular. So let's see. I'm just checking to see if there's any other questions. I do want to jump and stop right here on Silvestri though. Like I really want you all to see what I mean by like his games. And see, look at that. This is a new one. See, that is Match Zero. That wasn't even there before. So he has all sorts of stuff. Look at that. And all of these are like fun to do. I don't know if you remember that game called Wordle. It was on social media. Like he did one, but it's called Numble. And every day you got to figure out like what the numbers are. And you got so many tries, and then you have to try again the next day. So he does really cool stuff. Let me see. I'm gonna go back up here to Match Zero because this is a new one, and I'm curious to see what it is. It says identify and click on pairs of additive inverses to cancel them out and clear the board. Okay, so for those of us that don't do math or don't teach it or anything, when you hear additive inverse, you're just trying to add two numbers up and get zero, right? Anybody see a pair that I can put together to give me that zero? You just want to add two numbers up and get zero. Which two numbers can I click and if they add up, they're zero? 4 and -4. There we go. 4, -4. Boom, gone. So everybody see that? And literally, it's just a good way to, just get some practice. We got 2, -2. We got 3, -3. We have 8, -8. And then after a while, after getting these to start canceling out, and remember, I think this is the only instruction. I don't think he's even going to tell you what additive inverse means. You get what I'm saying? He's not going to even tell you what it means. It's like if you're able to get them to cancel out and you start to get more to cancel out, then they'll actually know what an additive inverse is, and then they can formalize it. And once they kind of discover it that way, 9 out of 10, they'll never forget it for the rest of their life. That's the great thing about discovery. So what happens if you're incorrect? What feedback you receive? So if I do, let's say I do -5 and -5. See that? Well, I do -5 and negative, it'll just turn red and I have to keep picking. So what we have? We got 6. We got that. I'm trying to see what happens when you clear the board. And remember, this wasn't there before, so he's actually added this to here. Okay, let's see what happens when we get to the very end. Oh, that's it. And then you just click to refresh board. You click here, and it just randomizes another set of numbers. So that's one of his games that he did. So it's a cool one right there. So Match Zero is a good one. Let's see. He had this other one that I got hooked on. I started playing it, and I was like, oh man, I got to get the highest score. And I'm trying to see. He has so many different ones. It was like one of his early ones. Okay, he had the zero sum. He has one with no timer, then he has one with a timer. Zero sum is it was similar, but what made this one more challenging is the first one that we just got finished doing, you had to do a pair. This one you have to add 3 things up to get 0. So it forces them to think a little bit harder on the negatives and the positive because they have to get 3 cards and the total has to equal 0. So notice this right here has a 2-minute timer, and it's going to keep counting how many you got correct within those 2 minutes. So, and the timer starts when I start, right? So before I start, I try to get my eyes on everything and make sure I have a good idea of what I'm about to choose to further my chances of getting the correct thing. That makes sense. So, like if I do 3 plus 2 minus 5, see that? 3 plus 2 minus 5, okay. So now I have -3, positive 6, right? I have, and see now I'm starting to, oh no. 6, 1, and then positive 5, boom. And then notice, and it really gets people, it really gets students kind of hooked in there because they're racing against the clock. They're racing against the clock and they're trying to get the highest score possible. Even if you're not turning this into a challenge with multiple students, just them doing it off on their own, whether it's overnight or wherever, they'll start to, really get into it. And then it gets them just better at, choosing or finding these triples. Let's see. I forgot what number. I'm trying to get 0, right?
Yes.
Do you see another pair? Because I'm starting to choke up now. They put the
somebody put it up there. -4, -2, 6.
Ah, -4, -2, 6. Thank you. There we go.
-1, -2, 3.
-1, -2. Is there a -2 here? It's not a negative.
They had it up there. Okay, it's not there. Okay, they put that up.
-1, -1, 2. Let's see what we got. We got nope. We got a 2 here. Nope. And then we got a 0 there.
3, 3. Somebody said a 3, 2, 3.
These 3s and a positive 6.
Oh, well, okay. Then you got a -3 and then the 3 itself. Oh, you need 3 of them though. Never mind.
Yeah, 3 to positive, and negative. And that's the challenge, right? It really changes the game when you have to think, and then boom, now the time ran out. I got 10 matches, right?
And I like it for the fact that they can actually go back and actually try to beat their own score. I love that too.
Exactly. You can beat your own score. It can be something. This could be a cool warm up, right? I don't know. Maybe they walk in class, and you're getting some papers together. You're calling the roll, whatever you're doing, right? while you're doing that, they can be doing the best that they can do, and then whoever has the highest score of the day, their name is on the board, and maybe they can have like some face off, or they can win prizes. I don't know. It's just however you see fit to motivate them to kind of focus in. But a lot of times, because it's turned into a game, they're already motivated as far as the score is concerned. So that's the main thing. It's like, how do you keep them motivated and engaged? He always designed games because there's a whole psychology behind games and why they're addictive, right?
Right.
So if you understand how that goes, he's great at designing things, because I think he had like a computer science background, even though he doesn't have to write code, but it's still that type of thinking that goes into designing these games, right? So that was one of the things. I don't know. He had this one right here was atoms, like, so that's like a science type of thing. A whole four. So using coordinates to put a golf into the hole. So he has different ways to really kind of get people into it, right?
On that last game, someone asked, could you adjust that time?
Let's see. I'm trying to think. There might be a roundabout way to do it.
Okay.
And let me see. Okay, so this is what I'm gonna try to do. I don't think I can right here, but if I click these three dots and I copy this activity, I think,
When you came over there, I saw it. Oh, that's just for the title, though, I think.
let's see. I'm gonna go under my account, and I have a copy of it. Now that I have a copy of it, if I go to edit activity, okay, I'm trying to see if activity settings. Let's see. I'm trying to see if there's a way around it. Because I've done something similar before. I just haven't done it with one of his games, where I copied something over to my account, and then I was able to kind of look under the hood and see how they created it, right? And I'm trying to see what's the way to do that. Contact author of the resource. He might have it locked a certain way where you can't really see under the hood and see how he created this. Possibly if you reach out to him, but I doubt he's gonna give up his the magic.
Right.
But I've done that before with a couple of things. I was able to kind of copy it, and then I was open, and then I saw what they did line by line. But I think he kind of prevented that. So I don't see another way to do it. That's one thing. Wait, hold up. Let's see. Edit. If I go to edit here, that's one thing. Hold on. Advanced settings. Oh, here we go. I think y'all don't tell on me, man. Please, y'all. Please don't be like, oh, he showed me how to do that. Please don't tell on me. Okay, you put me on the spot. Y'all put me on the spot, man. Y'all put me on the spot. But I'm gonna hit save again. Okay, let's see. Let me go back under here. Let me see. Let me see if I open this up. Will I see the okay? I'm getting close. Notice, see how I'm seeing more buttons and stuff.
Right.
What do I see? View. Oh. Booyah. Told y'all, but please don't tell on me. Don't tell on me, please. Whatever you do, don't tell on me. So this is from top to bottom how this was created. And so like I understand what this is. Like I understand what all of this means so far. Like I forget how many cards there were. How many cards were there? There was one, two. It might have been like 20 of them or more. Let me change the view.
I did see where you can change your grid at one point.
So we got 4 by 3. Let me Okay, a 4x3. 1, 2, 3, 4, 1, 2, 3. So there's 12 cards there, right? So I'm gonna go all the way up to the top. I don't know what these sliders things do, right? But what I do know is that these must be the cards. Well, maybe not. N21, N20. Let's count it. That's one. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think that has to do with the cards. And it's going to choose a random number between -9 and +9. So every time you run this game, it's going to keep randomizing all 12 of those cards. I know that's what this one does, right? Um, Now the sum, I don't know. I'm sure this is much longer. If
The
I
time
click it,
was right
I gotta
underneath
read it.
that.
So I mean, it looks very simple to do. So no one expects you to create this game, right? So like this is one of his passion things. So he created his own game. But this is kind of what I use to kind of figure out or try to get into the minds of people that have created certain things. And then whatever I can extract from that, I use towards something that I want to create. All right. So that's kind of, but yeah, this is all the magic behind the scenes. All right. So it's a lot of stuff there, as you can see.
And right before you clicked that, it looked like I saw time like 120 seconds underneath there. So that's what that
Oh,
means.
yeah. We looking for the time.
Yeah, and I
Oh,
think you
see, I done
saw
got off the mat. So let's see.
it. I saw it when you clicked. Right when you did after you did the cards, I saw it say
Oh,
time.
yeah.
Yeah,
So yeah, it's definitely in here somewhere.
I, it was right after you were
Is it
showing the
after this or
cards.
was it near the top?
It was when you were showing the cards after you
See,
counted the
there it is right
cards.
there.
Okay, yeah,
See that?
that wasn't the one I saw, but yeah, that's I guess that'll be the same one. Yeah.
So if we wanted to say, for instance, 60 times 2, right? That's 120. So that's 2 minutes.
Mhm.
So if I do 60 times 3 and I do 180, right? If I switch that to a 180, then 9 times out of 10, it might do it. Right. And at this point, I don't have any issue doing that. I'll change it just to see what happens and say, okay, I don't know. Well, let's see. And
Did
look,
change.
see that?
Yep.
It did change it. So if I wanted to go 5 minutes, I just change that to 300. You see what I'm saying?
Right.
Yeah, 300, 300, 300. And then boom, 5 minutes. So yeah, it can happen, but as you can see, you have to
Work
turn
for it.
yourself into like a hacker in a sense, right?
Got
But
to work for it.
but yeah, it's so cool because and notice once I copied it, notice how it has me down as an author and it has him down as an author. So he's going to continue to get credit for what he's created, but I did change it around a little bit though. But once again,
Remix
y'all please don't tell anyone that I showed you how to do this. Just be like, I don't know, I just kept clicking around, I figured it out. You know,
it.
I don't want to get mad at me like you gave them, you know what I'm saying? You showed them how to mess with my stuff. I was like, I'm just fair use. We're all teachers, man. Everything's up for grabs. Everything. But yeah.
Always.
Yeah, I was in the classroom. I mean, all I did was take stuff. Well, if I can use it, I take it. No permission. But yeah. But am I over my time? But yeah, I just kind of wanted to
You
see
right
what
at time, Doc. That was awesome.
Okay, so I'm gonna delete this one. Because I can always go back and make my own copy, but I'm gonna just delete that one for the time being.
Excellent. One
Yeah.
thing I would like to share too, when you said that about augmented reality, a lot of times when I'm sharing that with students, I tell them they're familiar with virtual reality. So we take ourselves and put ourselves in the virtual world. So when it comes to augmented reality, we take the virtual world and put it into our world. So help them
Exactly.
understand. Yeah, help them understand that
Mhm.
way.
Exactly. So yeah, yeah. Virtual reality, you throw on the headset, all this goes away, and you go
Mm-hmm.
into some la la
Mm-hmm.
land, right? It's
Right.
created by some computer programmer, and you're inside of a game.
Yeah.
But what happens when you take the game and put it in the real world? That's
Mm-hmm.
reality. So they're very
Yep.
similar, but
Yep.
the way that you interact with it is going to be slightly different.
Oh yeah. Thank you all so much for joining us today. Are there any questions?